There is a dream that has captivated the human imagination for the better part of a century, a dream that seems to grow more vivid, more urgent, and perhaps more desperate with every passing year. It is the dream of the red planet. When you stand out in a dark field on a clear winter night and look up, you can see it, that steady, unblinking ochre point of light drifting amongst the stars. It feels close. It feels tangible. And because it is a world, a solid, rocky world with a day length almost exactly the same as ours, with polar ice caps that wax and wane with the seasons, with canyons and mountains and valleys, we have convinced ourselves that it is a destination. We look at Mars, and we do not just see a planet, we see a future, we see a second home, we see the plan B for humanity. You hear it from visionaries, from billionaires, from science fiction authors, and even from space agencies. The narrative is always the same. We will build rockets, we will go there, we will build domes, and eventually we will terraform it. We will melt the ice, release the gas, thicken the atmosphere, and turn that dead red rock into a vibrant, green, living world. We will create a second Earth. It is a tremendously romantic vision. It speaks to something profound in our nature, that desire to explore, to expand, to conquer the unknown, to ensure that the light of consciousness does not flicker out in the dark. But here is the thing, and I think we need to be absolutely honest about this. However uncomfortable it might be, it is a fantasy. It is not just a difficult engineering challenge. It is not just a question of money or political will or waiting for the right technology to be invented. The barrier to making Mars a second Earth is not technological. It is fundamental. It is written into the laws of physics, into the history of the solar system, and into the very geology of the planet itself. Mars is not a sleeping beauty waiting to be kissed awake by human ingenuity. Mars is a corpse, and no amount of wishful thinking can bring a planetary corpse back to life. To understand why, we have to look past the surface, past the romantic images of dust storms and rovers, and look at the heart of the planet, or rather, the lack of one. You see, the reason Earth is alive, the reason you and I are breathing right now, the reason forests grow and oceans remain liquid, is not just because we are at the right distance from the sun. It is because Earth is a geologically active, violent, churning engine deep beneath our feet, thousands of miles down. There is a molten iron core, spinning and swirling. And because iron is a conductor, that movement creates a magnetic field. It creates a vast, invisible shield, the magnetosphere, that reaches out into space, wrapping around our planet like a protective cocoon. This shield is not a luxury, it is a necessity. It is the only thing standing between us and the violence of the star that we orbit. The sun is not just a benign source of light and heat. It is a nuclear fusion reactor. It constantly vomits out a stream of high-energy particles, the solar wind, moving at hundreds of kilometers per second. Without a magnetic field, that solar wind would strip away our atmosphere, tear apart the ozone layer, and bombard the surface with lethal radiation. On Earth, the dynamo is running. The shield is up. On Mars, the dynamo died billions of years ago. We are not entirely sure why. Perhaps Mars was too small to hold on to its heat. Perhaps a giant impact disrupted the flow. But whatever the cause, roughly 4 billion years ago, the heart of Mars stopped beating. The convection currents in its core ceased. The magnetic shield collapsed. And at that moment, the planet was sentenced to death. When the shield fell, the sun began its work. For billions of years, the solar wind has been scouring the Martian surface, stripping away its atmosphere, molecule by molecule, atom by atom, in a process called sputtering. It is a slow, relentless violence. The water that once flowed in great rivers and oceans on Mars, it boiled away into space or froze into the crust. The thick atmosphere that might have once supported life, it was blown away, lost to the void forever. This is the fundamental problem with the idea of terraforming Mars. We talk about nuking the poles to release carbon dioxide, or building factories to pump greenhouse gases into the air to thicken the atmosphere. And yes, in principle, you could perhaps increase the atmospheric pressure temporarily, but you are fighting a losing battle against the laws of physics. Because Mars has no magnetic field, any atmosphere you create, any gas you pump out, is immediately vulnerable to the solar wind. You would be trying to fill a bathtub that has no plug while the sun is actively scooping the water out. To make Mars truly habitable, to make it a second Earth where humans could walk outside without pressure suits, where rain could fall and crops could grow in the open air, you would need to restart the planetary dynamo. You would need to liquefy the core of a planet and set it spinning again. Think about the energy involved in that. We are talking about the thermal energy of an entire world. The entire nuclear arsenal of the human race, if detonated all at once, would not even register as a tickle on the scale of planetary geophysics. We do not possess, and we will likely never possess, the energy required to melt a planet's core. It is a thermodynamical impossibility. It is a scale of engineering that belongs to gods, not to biological organisms that have only just learned how to leave their own atmosphere. So when we look at Mars, we must strip away the romance and see the tragedy. It is a beautiful tragedy. Certainly, the Valles Marineris, that vast canyon system that would stretch from London to New York, is a testament to the geological violence of the past. Olympus Mons, the volcano 3 times the height of Everest, stands as a monument to a time when the planet still had internal heat. But they are monuments in a graveyard. There is a profound melancholy in this realization. When we study Mars, we are studying what happens when a world dies. We are looking at a path that Earth, fortunately, did not take. And this brings us to a critical point about our place in the universe. We tend to assume that planets are just stuff, real estate waiting to be developed. We look at the moon or Mars or the asteroids and we see resources, we see territory. We project our history of terrestrial expansion, of crossing oceans to find new lands onto the cosmos. But space is not an ocean, and Mars is not the new world. When European explorers crossed the Atlantic to the Americas, they found a world teeming with life. They found air they could breathe, water they could drink, soil in which they could plant potatoes and corn. They found a biosphere. It was different, yes, but it was fundamentally the same operating system. Biology, chemistry, physics, all working in harmony to support life. Mars is an alien environment in the truest, most hostile sense of the word. It is not just Earth but a bit colder, or Earth but with less air. It is a vacuum-sealed radiation chamber. The atmospheric pressure on the surface is less than 1% of Earth's. It is so thin that it is essentially a vacuum. If you were to step out onto the Martian surface without a pressure suit, it would not be like holding your breath underwater. The gases in your blood would bubble out of solution. The water on your eyes and tongue would boil instantly due to the low pressure, even as it froze due to the cold. You would fall unconscious within seconds and be dead within a minute. This is the baseline. This is the friendly neighbour we dream of colonizing. And even if we solve the pressure issue, even if we build vast airtight domes or burrow into the rock like termites, we are still trapped by the lack of a magnetosphere in another, more insidious way. Radiation, without that global magnetic field, and without a thick atmosphere to absorb it, the surface of Mars is bathed in cosmic rays and solar radiation. On Earth, we are protected. The air above our heads is equivalent to a shield of lead several meters thick. On Mars, there is nothing. A trip to Mars involves being bombarded by high-energy particles that shred DNA, that tear through cells like microscopic bullets. And once you arrive, you cannot simply live on the surface. You cannot build a glass dome and live in a house with a garden looking up at the stars, not unless the glass is several feet thick and filled with water or lead. To live on Mars is to live underground. It is to live in tunnels, in lava tubes, in windowless bunkers buried beneath meters of regolith to escape the cancer-causing rain of particles from the galaxy. Ask yourself, is that the future of humanity? Is that the grand vision? To trade the blue skies, the fresh breeze, the sound of rain, the smell of soil and grass, for a life in a cave on a dead world? To become a species of troglodytes, huddling in the dark, watching our bone density crumble and our eyes fail, just so we can say we have a backup? There is a dangerous hubris in thinking we can simply engineer our way out of these constraints. We look at the complexity of Earth, a system that has evolved over 4.5 billion years, a system where the geology, the atmosphere, the magnetic field, and the biology are all intricately locked together in a dance of perfect balance. And we think we can replicate it on a dead rock using a few nuclear explosions and some greenhouse gases. It reveals a lack of respect for what a planet actually is. A planet capable of supporting life is not a simple machine. It is a chaotic, non-linear system of infinite complexity. Earth is an anomaly. It is a freak of cosmic luck. The fact that our core is still hot, that our magnetic field is still strong, that our atmosphere is thick enough to hold heat, but not so thick that it crushes us, this is the exception. Mars is the rule. The universe is littered with dead worlds. To think we can turn the rule into the exception is to misunderstand the scale of the forces we are dealing with. We often hear the argument that we must go to Mars to ensure the survival of the species, that if something happens to Earth, an asteroid strike, a nuclear war, a runaway pandemic, we need a plan B. It sounds logical. It appeals to our sense of prudence. Don't keep all your eggs in one basket, but consider the reality of that plan B. Even after a total nuclear war, even after a massive asteroid impact, Earth would still be infinitely more habitable than Mars. The air might be radioactive, the sky might be choked with ash, the cities might be ruins, but there would still be an atmosphere, there would still be gravity, there would still be a magnetosphere, there would still be water. Recovering a damaged Earth is a project orders of magnitude easier than terraforming a dead Mars. If we cannot maintain the biosphere of the planet we evolved on, a planet perfectly suited to our biology, a planet that gives us air and water and food for free, what makes us think we can build a biosphere from scratch on a planet that wants to kill us? It is a form of escapism. It is a way of avoiding the hard truths about our situation here. It is easier to dream of building cities on Mars than it is to do the hard work of living sustainably on Earth. It is easier to imagine conquering a new frontier than it is to look after the one we have. And we haven't even touched upon the surface itself. Yet we have talked about the sky, the core, the radiation. But let's say you survive the vacuum. Let's say you survive the radiation. You look down at the ground beneath your boots. That red dust, the iconic signature of the planet, we think of it as soil. We think, oh, well, just add some water and some fertilizer and we'll grow potatoes like in the movies. But it is not soil. Soil is a living thing. Soil is a complex matrix of organic matter, minerals, bacteria, fungi, worms, insects. It is a biological entity as much as a geological one. The stuff on Mars is regolith. It is crushed rock. It is dead. But it is not just dead. It is toxic. And this brings us to a realization that is perhaps even more disturbing than the cold or the vacuum. The very ground on Mars is poisoned. As we move closer to the surface, as we land our imaginary ship and prepare to step out, we are not stepping onto a sandbox. We are stepping into a chemical hazard zone. The romantic red hue of the planet hides a chemistry that is fundamentally incompatible with human life. We are not just fighting physics, we are about to fight chemistry. And chemistry, as any biologist will tell you, is where the war for survival is truly fought. The challenge is not just keeping the air in, it is keeping the planet out. We have spoken about the death of the core and the thin radioactive whisper of an atmosphere. But let us now turn our eyes downwards. Let us look at what happens when you actually put your boots on the ground. Because if you do manage to survive the journey, if you do manage to land your spacecraft without smashing into a crater, you are going to want to step outside. You are going to want to build a settlement. You are going to want to live. There is a charming scene in The Martian, a film I quite enjoyed for its optimism, where the protagonist, stranded on the red planet, decides he is going to science the hell out of this. He brings Martian soil into his habitat, mixes it with human waste, adds some water, and voila, he grows potatoes. It is a wonderful celebration of human resilience. It makes you believe that with a bit of botany and a bit of grit, we can turn Mars into a garden. But chemistry is not sentimental, and the chemistry of the Martian surface is not just difficult, it is hostile. The dust that covers Mars, that fine, powdery regolith that gets into everything, is not inert rock. It contains high concentrations of perchlorates. Now, to a chemist, perchlorates are salts derived from perchloric acid. They are used on Earth in rocket fuel and fireworks. They are highly reactive oxidizers. But to a biologist, to a human being, they are simply poison. Perchlorates interfere with the thyroid gland. They block the uptake of iodine, which shuts down the production of hormones essential for metabolism and growth. If you were to grow potatoes in untreated Martian soil, assuming you could get them to grow at all, they would absorb these toxins. You would not be growing food, you would be growing poison capsules. Eating them would slowly destroy your endocrine system, and it is not just about eating them. This dust is everywhere. It is electrostatically charged. It clings to spacesuits, to airlocks, to machinery. When the Apollo astronauts returned from the moon, they were covered in lunar dust. It smelled like gunpowder and irritated their throats. On Mars, that dust is toxic. You would track it into your habitat. You would breathe it in. It would get into the water filtration systems. Living on Mars would mean living in a constant state of chemical decontamination. You would be fighting a war against the very ground you walk on every single day. So the idea of living off the land, the concept of in situ resource utilization that space agencies love to talk about, hits a chemical wall. You cannot just scoop up the dirt and use it. You have to process it. You have to wash it, treat it, separate the poisons. And where does the toxic waste go? You are in a closed loop system. There is no way to throw things to. But let's assume, for the sake of argument, that we solve the poison soil problem. Let's assume we build massive chemical plants to wash the soil before we plant our seeds. We are still faced with the question of energy. Life is an energy-hungry process. On Earth, the energy is free. It falls from the sky in the form of sunlight, filtered beautifully by our atmosphere to remove the harmful UV, while letting the visible light through for photosynthesis. On Mars, the sunlight is roughly half as strong as it is on Earth. That might not sound too bad, until you remember the dust storms. These are not the dust storms of the Sahara. These are global events. They can cover the entire planet, blotting out the sun for weeks, sometimes months at a time. Imagine being in a colony dependent on solar power, dependent on greenhouses for oxygen and food, and suddenly the lights go out, the temperature plunges, the plants begin to die, the batteries start to drain. You are sitting in the dark, millions of miles from home, listening to the wind howl outside, knowing that the only thing keeping you alive is a machine that is slowly running out of power. It is a fragility that we are not used to. On Earth, if a storm knocks out the power grid, it is an inconvenience. On Mars, it is an extinction event. And this brings us to the radiation again, but in a different context. We talked about it stripping the atmosphere, but let's talk about what it does to biology over time. Without an ozone layer, the surface of Mars is sterilized by ultraviolet light. Any microorganism that we might accidentally bring with us on the outside of a suit would be fried instantly. But the cosmic rays, high energy particles from exploding stars across the galaxy, they penetrate deeper. They punch through rock, they punch through metal, and they punch through you. If you are a colonist on Mars, your lifetime risk of cancer goes up dramatically. But it is not just cancer. It is cognitive decline. It is cardiovascular damage. It is the clouding of the lenses in your eyes. We are evolved for an environment where radiation is a background hum, not a heavy metal concert. Our DNA repair mechanisms are simply not up to the task. So the second Earth would effectively be a hospice, a place where human life expectancy is drastically reduced, where health is a constant battle, where the simple act of existing requires medical intervention. And yet, we persist with this idea that we can create a self-sustaining ecosystem. We think we can build a biosphere 2 on Mars. Do you remember Biosphere 2? It was a grand experiment in the Arizona desert in the 1990s. They built a sealed glass structure, filled it with rainforests, oceans, savannas, and locked 8 people inside. They wanted to prove that a closed ecological system could support human life. It failed. Within months, oxygen levels dropped so low the crew had breathing problems. Carbon dioxide spiked. The pollinators died, so the plants didn't reproduce. The water cycle went out of balance. Ant species exploded in population and overran the place. And this was on Earth. This was with free sunlight, with Earth's gravity, with help just outside the airlock. Ecosystems are not machines. You cannot just assemble them from parts. They are incredibly complex, chaotic webs of interdependence. We do not know how to build a self-sustaining ecosystem from scratch. We barely understand the one we live in. We rely on billions of invisible interactions, bacteria in the soil fixing nitrogen, fungi breaking down waste, insects pollinating flowers, plankton in the oceans producing oxygen. To think we can pack all of that complexity into a spaceship, fly it to a frozen, toxic, radioactive desert, and have it work perfectly is not science, it is hubris. But perhaps the most profound barrier is not the poison soil or the radiation or the cold. It is something much more intimate. It is us. It is our own biology. We are not just beings on Earth, we are beings of Earth. Every strand of our DNA, every enzyme in our cells, every structure in our bodies has been shaped by the specific physical conditions of this planet over nearly 4 billion years of evolution. We are tuned to Earth like a violin is tuned to a specific pitch. Consider gravity. Mars has 38% of Earth's gravity. We think, oh, that sounds fun. We'll be able to jump higher. We'll feel lighter. And for a few days, it probably would be fun. But the human body uses gravity as a signal. Our bones maintain their density because gravity pulls on them. Our hearts pump with a specific force because they have to work against gravity to get blood to the brain. In microgravity or low gravity, the body assumes it doesn't need to work as hard. It starts to dismantle itself. Astronauts on the International Space Station, despite exercising for 2 hours every day, lose bone mass, their muscles atrophy, their cardiovascular systems weaken, their eyesight changes because the fluid shifts in their bodies, flattening the back of the eyeball. And that is after just 6 months or a year. What happens after 10 years on Mars? What happens to a child born in 0.38? Gee, we don't know. But we can make an educated guess. Their bones would likely be too brittle to ever withstand Earth's gravity. Their hearts might be too weak to pump blood in a 1G environment. A child born on Mars would be a prisoner of Mars. They could never visit the home of their ancestors. They could never walk on a beach on Earth without being crushed by their own weight. We would be creating a new species, Homo martis, a species of fragile, tall, thin humans who can never leave their bubble. Is that the dream? To create a genetic offshoot of humanity that is forever exiled from the cradle of its civilization? There is a deep cruelty in that. We talk about colonization as if it is about freedom, about expanding our horizons. But for the people who would actually live there, and especially for their children, it would be a life of ultimate confinement. Imagine looking up at the sky from the surface of Mars. You see Earth. It is a beautiful, bright blue star. You can see the moon orbiting it if you have a telescope. You know, that on that blue dot, there are oceans and forests and bustling cities and music and art and billions of people breathing fresh air. And you are standing in a pressure suit, breathing recycled air that smells of chemicals, eating algae paste, knowing that if a seal breaks, you die, knowing that the dust outside is poison, knowing that you can never, ever go home. The psychological toll of that isolation is something we have not even begun to grapple with. We are social animals, yes, but we are also biological animals, deeply connected to our environment. We need the colour green. We need the sound of wind in the trees. We need the chaotic, messy, vibrant life of a biosphere. There is a reason why researchers in Antarctica, the closest analogue we have to Mars on Earth, though still infinitely more hospitable, suffer from winter over syndrome, depression, irritability, cognitive impairment, and they are there for only a few months. They have internet, they have good food, they know a plane is coming to get them. On Mars, the delay in communication is up to 20 minutes each way. You say hello, and 40 minutes later, you hear hello back. You cannot have a conversation with anyone on Earth. You are cut off. You are truly, profoundly alone. The sense of isolation would be crushing. It would be a solitude unlike anything any human has ever experienced. So when we strip away the CGI videos of glass domes and happy colonists, what are we left with? We are left with a toxic, radioactive, freezing desert where we would have to live in underground bunkers, eating synthetic food, slowly decaying in low gravity, cut off from the rest of humanity, fighting a daily battle against death. It is not a new frontier. It is a high-tech prison. And the question we must ask ourselves, the question that really matters, is why do we want this so badly? Why are we so eager to trade paradise for a wasteland? And this brings us to a barrier that is perhaps less visible than the radiation or the toxic soil, but infinitely more profound. It is a barrier that exists not in the rocks or the sky of Mars, but inside us. It is the barrier of our own evolutionary history. We tend to think of ourselves as independent entities, as if a human being is a piece of software that can be uninstalled from Earth and reinstalled anywhere else in the cosmos, provided there is oxygen and water. But we are not software. We are hardware. And that hardware was designed, prototyped, and refined by a specific set of environmental conditions over 3.8 billion years. We are not just on Earth, we are of Earth. We are an expression of this planet's physics, just as a wave is an expression of the ocean. The most relentless of these physical constraints is gravity. On Earth, every single cell in your body, every valve in your heart, every neural connection in your brain has evolved to operate in a gravitational field of 9.8 meters per second squared. It is the constant beat to which the music of our biology is played. But on Mars, the gravity is 38% of Earth's. It is a weak, ghostly pull. Now, we know from our experience on the International Space Station that the human body does not handle microgravity well. But the International Space Station is a temporary deployment. Astronauts go for 6 months, perhaps a year, and even then, they return with skeletons that have aged decades in months. They return with vision problems because the fluid pressure in their skulls has flattened their eyeballs, a condition known as SANS, spaceflight-associated neuroocular syndrome. They return with atrophied muscles and confused vestibular systems. But on Mars, there is no return. We are talking about living there. We are talking, presumably, about reproducing there. Consider the development of a human fetus. It is a process of exquisite complexity, a choreograph of cell division and migration that we still do not fully understand. We know that on Earth, this process is guided by gravity. The orientation of the fetus, the development of the skeletal structure, the formation of the heart valves, all rely on the presence of Earth's gravity. What happens to a fetus in 0.38 g? We do not know. It is an experiment that has never been performed, and to perform it would be an ethical nightmare. Does the neural tube close correctly? Do the chambers of the heart form the right thickness? Does the vestibular system, the delicate machinery of the inner ear that tells us up from down, wire itself correctly in a world where down feels wrong? There is a very real possibility that human gestation is simply impossible on Mars, that the pregnancies would fail, or that the children born would suffer from profound congenital deformities. But let us take the optimistic view. Let us assume that life finds a way, and a generation of children is born in the Martian colonies. They would be the first Martians, but they would be tragic figures. Growing up in low gravity, their bones would be longer and thinner, their hearts smaller and weaker. They would be tall, frail beings, adapted to a world of light steps and heavy suits. And here is the horror of it. They could never come to Earth, to a Martian-born human. Earth would be a crushing hell. The gravity here would feel nearly 3 times stronger than what they were used to. It would be like you or I walking around with 2 other people strapped to our backs. Their bones would snap. Their hearts would fail. They would be biologically exiled from the cradle of their species. We would be creating a speciation event. We would be splitting the human race into 2 distinct branches, Homo sapiens on Earth and some new fragile offshoots on Mars. And these 2 branches would be forever separated by the wall of gravity. A mother on Earth could never visit her grandchildren on Mars without risking her health. The grandchildren could never visit the grandmother without risking death. Is this the expansion of humanity, or is it the fracturing of it? Furthermore, we must look at the psychological landscape of this new existence. We often romanticize the isolation of the explorer, the lone figure against the elements. But the isolation of Mars is of a different category entirely. It is a solitude so absolute that it threatens the stability of the human mind. Consider the distance. Mars is, on average, 140 million miles away. Light, the fastest thing in the universe, takes anywhere from 3 to 22 minutes to cross that gap. This means that real-time communication is impossible. There are no phone calls on Mars, no video chats with loved ones back home. You say hello, and you wait 20 minutes for the person on Earth to hear it, and another 20 minutes to hear their reply. The internet, as we know it, would not exist. You would be browsing a cached local version of the web, always outdated. The news you receive from Earth would be history by the time it reached you. You would be living in a time capsule, permanently out of sync with the rest of the human race. And then there is the physical confinement. I want you to truly visualize the daily life of a Martian colonist. You are living in a tin can or a stone tunnel, buried under the ground to escape the radiation. There are no windows, or if there are, they are thick, multi-layered portals looking out onto a motionless, dead landscape. You can never feel the wind on your face. You can never feel the sun on your skin. If you did, the ultraviolet would burn you. You can never smell rain or cut grass or the salty tang of the sea. You are breathing recycled air that has passed through the lungs of everyone else in the colony 1,000 times, scrubbed and filtered by machines. You are drinking recycled water that was urine yesterday. Humans are not evolved for this. We are evolved for the savannah. We have a deep psychological need for nature, for green space, for the chaotic sensory input of a living world. We see this in prisons. Solitary confinement in a windowless cell is considered a form of torture because it breaks the mind. On Mars, the entire colony is a solitary confinement cell. The overview effect, that profound cognitive shift that astronauts experience when they see Earth from orbit, that sense of connection and fragility would be inverted. From Mars, Earth is just a bright star. It is a speck. You would look up at the night sky and see the place where everyone you ever loved, every song ever written, every flower that ever bloomed exists. And you would know that you are locked out. The psychological pressure would be immense. In Antarctica, at the research stations, they have a term for what happens during the long, dark winter, the winter over syndrome. People become irritable, depressed, paranoid. Fights break out over trivial things. And that is on Earth, with gravity, with air outside, even if it is cold, and with the knowledge that a plane can come in an emergency. On Mars, there is no rescue. If the water reclaimer breaks, you die. If the oxygen generator fails, you die. If a seal blows, you die. You are living with a gun constantly pointed at your head, held by the environment itself. The stress of that, the background hum of existential dread, would corrode the social fabric of any community. And what kind of society would emerge in such a pressure cooker? We like to imagine a utopia of scientists and explorers working together for the greater good, but history suggests otherwise. A Martian colony would be the ultimate totalitarian state. It would have to be. In an environment where resources are scarce and a single mistake can kill everyone, there is no room for democracy. You cannot have a vote on whether to open the airlock. You cannot have individual liberty when your personal oxygen consumption is a matter of public inventory. It would be a society of strict rationing, surveillance, and control. The air you breathe would be a commodity. It would likely be owned by a corporation or a government. Think about the power dynamic there. If you go on strike, they don't fire you. They turn off your air. It is the ultimate company town. And who would go? The billionaires talking about this vision are not the ones who will be scrubbing the latrines or mining the toxic ice. It will be people signing away their lives for a dream, only to find themselves essentially indentured servants on a prison planet, working to pay off the debt of their transport with no way to return. We are not building Star Trek. We are building a high-tech dystopia. There is a concept in biology called an evolutionary trap. It happens when an organism makes a choice based on cues that used to be beneficial but now lead to a dead end, like a sea turtle mistaking a plastic bag for a jellyfish. Mars is an evolutionary trap for humanity. It looks like a new frontier. It looks like the next step, but it is a cul-de-sac. We are dazzled by the technology, by the rockets landing in unison, by the shiny renderings of glass domes. We are seduced by the narrative of destiny, but we are ignoring the biological reality. We are soft, wet, fragile creatures who evolved in a warm, magnetic embrace. We are not built for the void. And deeper than the biology, deeper than the psychology, is the philosophical error we are making. We are treating the universe as if it is merely a backdrop for human drama, as if planets are just empty houses waiting for us to move in. But the universe is not passive. It is violent. It is indifferent. Mars does not care if we are there. It does not care if we live or die. It will not cooperate with our attempts to terraform it. The winds will blow the atmosphere away. The radiation will degrade our plastics and our DNA. The cold will seek out every crack in our insulation. To live there is to be at war with nature, every single second of every single day. On Earth, nature is our cradle. On Mars, nature is our assassin. Why would we choose this? Why would we choose to sentence our descendants to a life of confinement, frailty, and fear? The answer, I think, lies in a story we tell ourselves, a story about survival. We are told that we must become multiplanetary to ensure the survival of the species, that if we stay on Earth, we are vulnerable, that we need an insurance policy. But this argument, which sounds so logical, so prudent, is actually the most dangerous illusion of all. It is based on a fundamental misunderstanding of what makes human life possible, and it provides a convenient moral escape hatch that allows us to ignore the gathering storms on our own horizon. It is this dangerous escapism that we must finally confront, because the belief that Mars can save us is not just a scientific error, it is a failure of responsibility. There is a concept in economics and insurance known as moral hazard. It describes a situation where a person or an entity takes greater risks because they believe they are protected against the consequences. If you have comprehensive insurance on your car, you might drive a little faster. If a bank knows the government will bail it out, it might make riskier investments. The narrative of Mars as a backup planet is the ultimate moral hazard for the human race. When we tell ourselves that we can simply leave, that we can start again, that Earth is merely the first stepping stone in a galactic expansion, we devalue the ground beneath our feet. We begin to treat the biosphere, this thin, fragile, miraculous layer of life, as disposable. We look at the rising oceans, the burning forests, the collapsing biodiversity, and a part of our collective psyche whispers, it's a shame, but it's okay. We have a plan B. We are going to Mars, but we are not going to Mars. Not in any meaningful numbers, and certainly not to survive a catastrophe here. Think about the logic of this for a moment. Imagine Earth has been devastated by climate change. The temperature has risen by 4 degrees. The weather is violent. The crops are failing. It is a nightmare scenario. But even in that nightmare, Earth is still a paradise compared to Mars. The air might be hot, but you can breathe it. The rain might be erratic, but it falls. The gravity is normal. The radiation is shielded. To suggest that we can escape a damaged Earth to survive on a dead Mars is like suggesting that if your house catches fire, you should move into a freezer in the garden that has no air, no food, and is being bombarded by X-rays. It is not a backup. It is a suicide pact. And there is an ethical darkness to this lifeboat mentality as well. If we were to build these colonies, who would go? Who gets the ticket? It would not be the poor, the vulnerable, the people most affected by the degradation of our home world. It would be the wealthy, the powerful, the select few. We would be channeling the resources of our civilization, trillions upon trillions of dollars, the finest minds, the greatest engineering efforts, into building a sanctuary for a handful of people, while leaving billions behind to deal with the consequences of our neglect. It is a distraction. It is a dangerous, seductive distraction that siphons our attention away from the only problem that really matters. How do we live sustainably on the only planet that can support us? When we look at the universe, really look at it, we see something that should make us tremble with gratitude. We see the great silence. We have been listening with our radio telescopes for decades. We have been scanning the stars for signs of engineering, for signals, for beacons, and we have found nothing. The Fermi paradox, where is everybody, remains the most haunting question in science. We see a galaxy of 400 billion stars, most with planets, and yet the only place where we know for a fact that consciousness exists, that music exists, that love exists, is here. Mars is not just a planet, it is a mirror. It shows us the default state of the universe. The universe is not a garden waiting to be tended. It is a nuclear furnace. It is a vacuum. It is a place of violent impacts and freezing cold. The silence of Mars, the deadness of its rocks, the stillness of its dunes, that is the norm. Earth is the aberration. Earth is the freak accident. To look at Mars is to realize how incredibly lucky we are. We won the cosmic lottery. We are standing on a world where the core is hot, the magnetic field is strong, the atmosphere is thick, and the distance from the star is just right. We are surrounded by a web of life so complex and so beautiful that we have yet to catalogue a fraction of it. And yet we are bored. We are like spoiled children sitting in a palace, dreaming of playing in the toxic waste dump next door because it seems adventurous. We need to redefine what it means to be an advanced civilization. For the last century, we have defined advancement as expansion, bigger, further, faster. We judge a civilization's success by how much energy it consumes, how much territory it controls. We talk about the Kardashev scale, measuring civilizations by whether they can harness the power of a planet, a star, or a galaxy. But perhaps that is an adolescent view of maturity. Perhaps a truly advanced civilization is not one that spreads like a virus across the stars, consuming and moving on. Perhaps a truly advanced civilization is one that learns to live in equilibrium with its home, one that achieves stability, one that values depth over breadth, quality over quantity, sustainability over conquest. There is a profound humility in accepting our limits. We are earthlings. That is not a derogatory term. It is a statement of biological fact. We are made of this dust. We are hydrated by this water. We are animated by the energy of this particular star, filtered through this particular atmosphere. Does this mean we should stop exploring? Absolutely not. We should send our robots to Mars. We should send our rovers, our drones, our sensors. We should study it with all the passion and curiosity that defines our species. We should learn its geology, map its canyons, understand its history. We should build telescopes to peer into the atmospheres of exoplanets light years away. We should seek to understand the fabric of reality itself. But we can do all of that without physically colonizing these worlds. We can love Mars for what it is, a majestic, scientific treasure chest, without trying to force it to be what it is, not a home. There is a Japanese term, wabi-sabi, which celebrates the beauty of imperfection and impermanence. But there is also a need for a new philosophy of space, one that celebrates the beauty of unreachability. But we need to learn to look at the night sky and appreciate that we cannot have it all, that some places are for looking, not for touching, that the stars are beautiful precisely because they are distant and hostile. By accepting that Mars will never be a second Earth, we are forced to turn our gaze back to where it belongs. Imagine if we took the enthusiasm, the capital, and the engineering genius currently being pitched at colonizing Mars and directed it towards Earth. Imagine if we treated the restoration of the Amazon rainforest, or the cleaning of the oceans, or the decarbonization of our atmosphere with the same moonshot intensity that we apply to building rockets. We could build a paradise here. We don't need to terraform Mars, we need to re-terraform Earth. We need to heal the damage we have done. We have the technology, we have the resources. The only thing we lack is the focus, because we are too busy looking up, dreaming of escape. I am reminded of the image taken by the Voyager 1 probe as it left the solar system, the famous pale blue dot. Carl Sagan spoke so eloquently about it. He reminded us that on that pixel, that mote of dust suspended in a sunbeam, everyone you love, everyone you know, everyone who has ever lived out their lives, but the context of that image is the darkness around it. That is what Mars teaches us. It teaches us about the darkness. When you stand on Mars, virtually, through the eyes of a rover, and look back at Earth, you see a star, a single bright star. If you were a colonist there, trapped in your tunnel, slowly succumbing to radiation sickness, watching your bone density fade, that star would haunt you. It would remind you of the wind. It would remind you of the sound of birds. It would remind you of the feeling of rain on your skin, a sensation no Martian colonist will ever feel again. We must not let that become our future. We must not let our romanticism lead us into a trap. The universe has given us a clear message. It has placed us in a quarantine of distance and hostility. The speed of light is a cage. The radiation of space is a wall. The gravity wells of planets are deep prisons. But this prison is not a punishment. It is a sanctuary. The universe is telling us as clearly as it can, here, this is it. This is your place. It is time to grow up. It is time to abandon the teenage fantasy of running away from home when things get difficult. It is time to do the hard adult work of cleaning up our room. We will not go to Mars to live. We will not build cities in the clouds of Venus or under the ice of Europa. We will not conquer the galaxy. We will live here. We will die here. And if we are wise, if we are careful, if we are kind to one another and to the biosphere that supports us, our descendants will live here for millions of years to come. They will look up at the red planet in the night sky, just as we do. They will admire it. They will study it. They will write poems about it. But they will not envy it, because they will know with a certainty that we are only just beginning to grasp that they are already in the best place in the universe. We do not need a second Earth. It is a fallacy to think we need more. It is a greed that blinds us to the abundance we already possess. Look around you. Look at the complexity of a single leaf. Look at the chaos of a breaking wave. Look into the eyes of another human being. This is enough. It is more than enough. It is everything